Let's draw Lewis structures for the nitrogen trifluoride and sulfur dibromide molecules. So I have the steps up here on your screen to follow along. So let's do nitrogen trifluoride first. Count the number of valence electrons. The nitrogen contributes 5, and each fluorine contributes 7. So that's 21 plus 5 is 26 valence electrons to work with. Nitrogen is less electronegative. Fluorine is the most electronegative, so it's never going to go in the center. So let's put nitrogen surrounded by 3 fluorines. Let's make a bonding pair between the terminal and the central atom. So that's going to eat up 6 of our electrons. So we're down to 20 valence electrons. Now let's give the terminal atoms the octet. Each of the fluorines already have 2 electrons from the bonding pair with the central nitrogen. So giving them 6 will complete the octet for each of them. So now we're down to 2 valence electrons because we just used 18 of them on fluorines. So the remaining 2 can go on the central nitrogen, and now they all have an octet. Let's take a look at their VSEPR geometry. So around the central atom, there are 4 electron domains. So when you have 4 electron domains, the parent geometry is going to be tetrahedral, but because only 3 of them have bonds to atoms, the geometry is going to be a trigonal pyramidal. And the bond angles, because the lone pair to bonding pair repulsion is greater than the bonding pair to bonding pair repulsion. In other words, these lone pairs are going to repel those bonding pairs slightly more than the bonding pairs repel each other. So the bond angle is going to be slightly less than, or less than 109.5. I'm going to redraw this so it's a little bit more three-dimensional. So we got nitrogen there. We got one of the fluorines here. We can use a wedge to bring it out, and then a dash to bring it behind. And there's our lone pair. Any one of these fluorine, nitrogen, fluorine bond angles you can say is less than 109, a little bit less than 109 degrees. Let's tackle sulfur dibromide next. Sulfur is going to contribute 6 valence electrons, and bromine, another halogen, is going to contribute 7, and there's 2 of them, give us 20 valence electrons to work with. Now sulfur is slightly less in electronegativity than bromine. So sulfur is going to be the central atom. Let's draw that, surrounded by the 2 bromines. Let's draw a bonding pair connecting the terminal to the central atoms. That's going to eat up 4 of our electrons, and we're down to 16 valence electrons. Now let's give the terminal atoms the octet by placing 6 valence electrons around each of the bromines. So that used up 12. We're down to 4 valence electrons, and those will go around the central atom, the sulfur. Now let's take a look at the geometry around the central atom is sulfur. So there, again, there's 4 electron domains, and so the parent geometry is going to be tetrahedral, but only 2 of the 4 are connected to other atoms. So this is going to give us a bent shape. Again, we have lone pair repulsions, which are greater than the bonding pair to bonding pair. So this is going to be, again, slightly less than 109. I'll draw this a little more three-dimensionally. So here's our sulfur. Here's 1 bromine. Let's see here. Let's go this way. This one's coming out at you. And then there's a lone pair there, and then a lone pair there. This here is less than, you would expect it to be less than 109.